Make sure you put your name, date, and period in the top right-hand corner. The title of this note is Chain Rule, and your outcome is to be able to use the chain rule to find the derivative of composite functions. So we're going to start with a really basic function. Find the derivative of y equals 6x minus 10. And using our old rule, the power rule, y prime would be the derivative of this first piece, which is just 6, and the derivative of the second piece, which is 0. So I wouldn't write anything. So we know the derivative is 6. But we could also write y as, let's see, there's a GCF there of 2. So I could also write y as 2 times 3x minus 5. Because if I distribute that 2, it'll give me back 6x minus 10. And really what's happening here is I have a composite function where the first function is, the outside function is 2 times the input, and then the input is 3x minus 5. So I could rewrite y as 2u if u is my input of 3x minus 5. So the derivative of this piece, normally we call it dy dx, but the variable is not x, it's u. dy du is 2. And then the derivative of the second piece, again, normally we call it dy dx, but it's not y anymore. The output is now u. So du dx is, take the derivative of this, derivative of 3x is 3, derivative of negative 5 is 0. Okay, I know the answer is 6. So how do I get dy dx out of these two pieces? Well, if I multiply them together, I will get 6. So the derivative is dy du times du dx. That's a y. So that is the chain rule. It's not useful for that super easy function, but it's going to become useful as we get more and more complicated functions. So here's the official definition of the chain rule. And there's two ways to look at it. If you think of a composite function as f of g of x, so you have an outside and an inside function, you take the derivative of the outside, all right, derivative of the outside times the derivative of the inside. And that really is the simplest way to think of it. Derivative of the outside times derivative of the derivative of the outside times derivative of the inside. Another way to think about it is you can change your inside function. Let's call it u. This is u substitution. So we're going to replace the inside function g of x with u. So in that case, we're going to have basically f prime of u times u prime. Derivative of the outside, which is f, times derivative of the inside, which is u. This is f prime of u, and this is u prime. And just like we saw on the last page, we multiply them together. So two different definitions that are both representing the chain rule. Now, sometimes the chain rule can have more than one chain. So here's an example of a 3-link chain. And there is no limit to how many links you have. You just keep on chain ruling. So I'm going to use that verbal definition, derivative of the outside times derivative of the inside. So my outside function is tangent of the input. Okay, my input is t, by the way. So I am doing, this is g prime, or I would call it dy dt, because I'm changing the output with respect to the input, which is t, dy dt. So I'm going to start with the outside. The outside is tangent. The derivative of tangent is secant squared. And then I'm just going to copy the input. So 5 minus sine 2t. And then what the chain rule says take this, and I'm just going to move it because I need more room. Take this and multiply it by the derivative of the inside function. So the inside function is this stuff right here. What is the derivative of 5 minus sine 2t? Take it piece by piece. The derivative of 5 is 0, so I don't need to write that. The derivative of negative sine. The derivative of positive sine is cosine. So the derivative of negative sine is negative cosine. All right, this has another inside function, so I'm going to move inside again. Here's the insidemost piece. So I have derivative of the outside times derivative of the inside times derivative of the inside of that. The inside of that is 2t, and the derivative of 2t is 2. I do want to simplify wherever possible. I like to put my coefficients first. So I have 2 and I have a negative sign. So I'm just going to rewrite this as negative 2. You might think you can combine secant and cosine, but notice how they have different inputs. If they have different inputs, you can't combine them. So I'm just going to go ahead and copy them. And it doesn't matter which one goes first, because we're multiplying. It's cosine 2t. All right, so that is the derivative of g of t. You want to make sure it's obvious what goes with secant and what goes with cosine. So I'm actually going to put a dot in between those two, so it's super obvious that this piece is one group and that piece is one group. You could also try using the square brackets to help. So that's it for the chain rule. I could keep going. You can just keep adding links. Derivative of the outside times derivative of the inside times derivative of the inside of that times derivative of the inside of that, ad nauseum. Just keep going. So go ahead and draw your line for your summary and bring your notes to class.